Okay, hello guys. My name is FISEHA TADDESE and today I'm going to give you some explanation about my digital assignment. My microcontroller is STM32L476RG. It is one of microcontrollers which is produced by the company called STM Microelectronics Company. And its manufactured year is 2016. Okay, when we get to the question, first draw the clean block diagram of the microprocessor or the microcontroller and the IP core selected. So as you can see, this is the block diagram of my microcontroller. As you can see, there are different kind of sections in the block diagram which have different kind of functions. As you can see, there is an HB-bus matrix, these are essential for transferring data from one place to the other place. Okay, and this next block diagram is the detailed block diagram of my selected microcontroller. As you can see in here also there are different kind of parts which are essential to the microcontroller. As you can see, there is a flash memory around here, and there is some kind of ports around here which are used for accepting inputs, and also there are different kind of things. There are UART. These are some kind of output ports which used to send data to any, it might be any sensor or it might be any other electronic device. Okay, second question, provide the instruction set of microprocessing elements. So what are the instruction sets that are contained in the selected microcontroller? Actually there are more than 64 instruction set in here. As you can see, there is ADC or ADCS, which is used to perform the operation to add with a carry, and it also has flags. I'm going to explain about the flags later. But as you can see, there are various kinds of instruction set which are contained in the selected microcontroller. There is a data memory barrier, there is if-then condition block, and this instruction set have their own operations. As you can see, it's put in clear manner. For example, we can take an example right here, like SHAD16, which is used to add two signed having 16-bit data. It used to add two numbers and have the value of that number, but the number should be a 16-bit data. And this, there are more instruction set. As you can see, the conditional flags, I told you earlier that I'm going to explain the conditional flags. The conditional flag N, it is set to 1 when the result of the operation is negative and otherwise it is cleared to 0, and Z, it is set to 1 when the result of the operation is 0 and otherwise it's cleared to 0. C set to 1 when the operation results in carry, otherwise it's cleared to 0. So the flag C will be set to 1 when there is a carry. It might be during addition, multiplication, or any arithmetic operation. And the flag V will be set to 1 when the operation causes an overflow, otherwise it's cleared to 0. These are the conditional flags which are used in the instruction sets of the selected microcontroller. And the next question explores the microprocessing element architecture. When we see about the architecture, the main system consists of a 32-bit multiplayer AHB or an advanced high-performance bus, and the bus matrix that interconnects up to 6 masters. The 6 masters include Cortex M4 with FPU Core ID bus. I'm going to explain this later. As you can see, there are 6 masters here, and there are up to 8 slaves, which are internal flash memory on the I-code bus, internal flash memory on D-code bus, and internal SRAM 190 KB for STM L47X and L48 series. As you can see, my controller belongs into the STM32L47 or L48 series. So in general, the architecture contains up to 6 masters and up to 8 slaves. Just to summarize, the system architecture look like this. As you can see, I already explained what core M4 FPU, and there is an I code, D code, and here are the SRAM, SRAM2. These are actually we can call this as memory management. So what are SO? SO means, I think this, if you see my cursor around here, this one, SOI bus. So what's the function of the SOI bus? This bus connects the instruction bus of the Cortex M4 core to the bus matrix, and bus is used by the core to fetch instructions. So this bus have a role in fetching the instruction. Next one, S1D bus, and this bus connects the data bus of the Cortex M4 core. As you can see, the Cortex M4 core means this one, and this bus is used by the core for literal load and debugging access. Its role is for literal load and debug access. And S2S bus, this bus connects the system bus of the Cortex M4 core to the bus matrix, and this bus is used by the core to access the data located in the peripheral or SRAM area. I told you that SRAM area lies in the right of the system architecture, as I showed you before. And the S3 and S4 DMA bus, this bus connects the advanced high level bus master interface of the DMA to the bus matrix, and the targets of this bus are the SRM1 and SRM2. Okay, so these are the purpose of different parts of the architecture. Okay, fourth question: correlate the microprocessing element architecture with the architecture discussed in module 1 and 2. Okay, in our module we see two architectures, which are von Neumann architecture and Harvard architecture. When we see von Neumann architecture, the memory, we have a single read-write memory available for read and write instruction and data. When we talk about memory, it's nothing but a single location which is used for reading and writing instruction for the data, and instruction are also present in it. As you can see, if we see the control process unit or the control unit, at the same time the logic unit lies in the same place, and we do have input device and output device, and we have memory unit. So this is the von Neumann structure. And when we get to Harvard architecture is used when the data and the code present in different memory blocks. As you can see, the instruction memory, control unit, and the data memory are placed in different kind of place. So for this kind of architecture we use the Harvard architecture. But whereas in my microcontroller selection, main system consists of a 32-bit multi-layer and advanced high-performance bus matrix that interconnects up to 6 masters. I already showed you 6 masters and its 8 slaves. Those facilitate data transfer. Elaborate register organization of microprocessing elements. So what kind of register found in my microcontroller? Namely, there are 16 registers in STM32L47RG microcontroller. The first one is auxiliary control register. As you can see, it's clearly stated. And Cupid based register, interrupt and state register, and vector tablet offset register, system control register, configure and control register, system handler priority register, system handler control and state register, configure fault status register, fault status register, bus fault status register, memory management fault address register, hard fault status register, memory management fault address register, bus fault address register, and auxiliary fault status register. Each and every register have their own operation and their own role in the microcontroller. For instance, if we take the auxiliary control register, it is cleared upon a power set and it's not affected upon other type of reset. It's explained about its operation. And the Cupid base register contains the processor part number, version, and also implementation information. And interrupt control and state register provide a set pending byte for non-makeable interrupt exception, set pending and clear pending bits for the pend SEV and C-stick exception, and it indicates the exception number of the exception being processed. So these are some of the use of the register, and each and every register, I mean the rest of the register, have their own use. Okay, when we get to the next question, so explain the type of the algorithm used for signed and unsigned calculations. That include addition, multiplication. In my case, there is a division and subtraction also. So when we get to the algorithm used for signed calculation, those are SAD 16 and SAD 18. This is the instruction which are used to add signed add 16-bit data and signed add 8-bit data, and it has its own operation. And there is the next shacks and shacks. These two data used to signed half add and subtract with exchange, and signed halving subtract and add with exchange. It's their purpose. They're going to use us to sign a half add and subtract with exchange data. And the next one is SHUP 16 and SHUP 8. They are used to signed half subtract 16-bit data and signed halving subtract 8-bit data. And next one is S sub and S sub 16 and S sub 8, which is used to sign subtract 16 and sign subtract 8. Used to subtract 16-bit data and used to subtract 8-bit data, but the data are signed. And next is SAX and SSAX, which used to signed add and subtract with exchange and signed subtract and add with exchange. So what are the algorithms used for unsigned calculations? Okay, when we get to the unsigned calculation, there is U add and U add 8 and U add 16, which is used to add unsigned 16-bit data and used to add unsigned 8-bit data. Next one, U AX and U SAX, which are used to add and subtract with exchange and subtract and add with exchange. So next one is U had and U had 8, which are used to add unsigned having add 16-bit data and unsigned having add 8-bit data. So the next one is U hacks and U shacks, which are used to add unsigned having add and subtract with exchange and unsigned have subtract and add with exchange. Next one is use add 8, which is used to add or used to sum unsigned sum of absolute difference. And next one is use add 8 and which is used to unsigned sum of absolute difference and accumulate. Next one is U sub 16 and U sub 8, which is used to subtract 60-bit data and subtract 8-bit data respectively. So what are the multiply and the divide instruction for signed and unsigned data? These are the multiply and as you can see it mentioned in table briefly, and it has their own brief description with their syntax also. For example, for instance, if we take MLA, which is used to multiply with accumulate and set to bit result, and MLS, which are multiply and subtract, which are a set to bit result, same thing, and MUL, which is used to multiply and set to bit result. At the same, each and every syntax have their own role, as you can see, and it's explained briefly. So next question, find what type of control logic unit used and correlate its performance with the type of controller unit in module 3 in COS syllabus. So in the selected microcontroller, The system block, which is called the system control block, is used as a logic unit, and it performs arithmetic logic unit operations like arithmetic operations. So the system control block provides system implementation information and system control. This includes configuration, control, and reporting of the system exceptions. Okay, so and it involves the following register in order to operate. As you can see, the register address is given, and here is the name, and their types also included, and what kind of privilege they have, and their reset value also mentioned here. So these registers are used with the system control block, and it works as a logic control unit. So in contrast with the control logic unit available in our module 3, in the system control unit, microprogram logic unit type is used. Okay, in the selected microcontroller, in my microcontroller choosing, a unit microprogramming logic unit is used, and also there are a responsible unit for arithmetic and float pointing operation. In addition, this system control unit do control and reporting the system exception with the use of different kinds of register. I already showed you what kind of register does this system control block unit use, and this register have their own uses for the operation to perform as a logical control unit. And next question, explain memory management system in the process element selected. So what kind of memory organization is reside in the selected microcontroller? So when we see the memory organization, program memory, data memory, register, and IO ports are organized within the same linear 4 GB address space. The bytes are coded in memory in little Indian format, and the lowest number byte in a word is considered the word's least significant byte, and the highest number byte is the most significant. And the addressable memory space is divided into 8 main blocks, of each containing a 512 megabyte space. And when we see the memory region types and attributes, the memory map and the programming splits the memory map into regions. Each regions have a defined memory type, and some regions have additional memory attributes. The major types and attributes determine the behavior of the access to the region. So when we see about the memory mapping technique, the memory mapping technique used in this microcontroller is associative mapping, and from this diagram you can easily see that what kind of memory mapping system is the selected microcontroller. As you can see, this is the memory mapping technique. Okay, next question, elaborate the pipeline and parallel processing capabilities of the error and hazard management technique. So what are the pipelines reside in the selected microcontroller? The pipeline system performed in select microcontroller can be classified into two, which are without prefetch and with prefetch. And as you can see the pipeline operations from the diagram clearly. And with prefetch, these are operations of the pipeline operations. Okay, and when the code is not sequential or branch, the instruction may not be present in the currently used instruction line or in the prefetched instruction line. In this case, the penalty in terms of the number of cycles is at least equal to the number of wait states. So this is a little explanation about the pipeline. Next question is, find whether the processor level parallelism is available in the element selected, and illustrate cache coherence and protocol used for handling memory HIT or miss. So what are the cache memory used in the selected microcontroller? So the first one is instruction cache memory, which is or called as iCache. It is used to limit the time lost due to jump, and it's possible to retain 32 lines of 4 by 64 bits in each instruction cache memory, and this feature can be enabled by setting the instruction cache enable or ICEN, and each time this occurs, request data not present in currently used instruction line in the previous instruction line or in instruction cache memory. So the line read is copied into the instruction cache memory. So in short, that's the instruction cache memory. It is used to limit the time lost due to jumps. So the next cache memory organization is D-cache, or called data cache memory, or when we see about its operation, its literal pulse are fetched from flash memory through the decode bus during the execution stage of the CPU pipeline. And each decode bus read access fetch 64 bytes which are saved in a current buffer, and the CPU pipeline is constantly stalled until the requested literal pool is provided. And to limit the time lost due to literal pool access through the advanced highly bus data bus and decode have priority over access through the advanced highly bus instruction bus, which is I code. Okay, I think okay, that's all about the explanation about my digital assignment. Thank you for giving your attention.